Welcome. Let's discuss the geometry regions for January of 2023. Let's start with question number 1. In the diagram below, there's a line reflection followed by a rotation. And what it does, it gets triangle ABC, which we have it here on the left, and it maps it into triangle DEF, which we have it here on the right. Well, when we're using either a reflection and a rotation, this is what we call a rigid motion. The shape will not change dimensions, only the location. So we're going to end up with congruent triangles. And if we have congruent triangles, then we have congruent parts. So now what we have to do, we just gotta match whose part is congruent to who. The way that we make our statements about congruency, it will tell us which part is congruent to which part. AB are the first two letters in the triangle ABC, and DE are the first two letters in the triangle of DEF. Well, the line segment of AB, it will be congruent to the line segment of DE. We're just matching location. And then we can go on circle. BC is the second and the third letter. Well, that section is going to be congruent to the second and the third letter, which in this case is EF. And lastly, the third letter with the first letter, CA, that's going to be congruent to the first and the third letter, which is FD. So the way that we make our statement about congruency, it will tell us who is congruent to who. And out of the options that we have in here, option number 1 is the one that makes the most sense. BC, which we have it here, the section in purple, it is congruent to EF, the section that we have here, which is what we also showed as purple. Let's move on to the next question. In question 2, we have a circle that is continuously rotated about its diameter. Let's picture that. So here we have our circle. Now let's draw its diameter. Now, if we get the circle and we start rotating about its diameter, then this point that we have in here, it's going to land on the other side of the circle. And the point that we have in here is going to land on the left-hand side of the same circle. And that is going to be true for all points. Like if I would have chose this point after the rotation, it's going to land somewhere on the right. And whatever I have on the right, once it gets rotated, it's going to go to the left. And when we keep doing this, notice that essentially what we are creating, it is a sphere. Which is option number 3. Let's take a look at the next question. In question number 3, we are being given a triangle. And then in addition, we are also given information that LA is parallel to CR. We're also being given some measurements. CL is 3.5. LE is 7.5. EA is 9.5. And what we're interested on is the length of AR. Let me call that X. Well, anytime that we have the following scenario, where we have a triangle, and then we introduce a line that is parallel to the base, the sides of the triangle are going to be in proportion. So let me use the same lettering as we have in our figure. This is point E, this is point L, C, R, and A. And that proportion is, if I take a look at the upper section in the left-hand side, and I divide it by the lower section still on the left-hand side, that is going to be the same on the right-hand side. If I take the upper section and I divide it by the lower section. We are always obtaining this proportion. Now, let's plug in the information that we have. EL, we have it as 7.5. CL, we have it as 3.5. EA, we have it as 9.5. And AR is the unknown. So let me call that X. And now that we have this proportion, let's solve for X. We can perform cross multiplication in here. And now we're going to get X times 7.5. And that is going to be equal to the proportion in the right-hand side. 3.5 times 9.5. And if we wish to solve for X on the left-hand side, let's divide 7.5 on both sides. So now we have an expression that we can use to find X. 3.5 times 9.5, if we divide that by 7.5, we will obtain the value of X. And if you do this in your graphing calculator, we're going to get approximately 4.4, which is option number 2. Let's take a look at the next question. In question 4, we are given a right triangle. Let's call it ABC. And what we want to know is which trigonometric equation is always true for this triangle. Well, when we take a look at all the options, there's always a relationship between sine and cosine. When we are working with the right triangle, there's always going to be a relationship between the sine and the cosine function. They are what we call CoFunctions. When we take a look at our right triangle, we have one angle that is 90 degrees. There's two more angles in this triangle, angle C and angle of A. If I take the sine of one of those angles, let me choose C, well, that's always going to be equal to the cosine of the other triangle. Of the other angle in this triangle, which is of A. The other way around, it's also true. The cosine of angle C, it is equal to sine of the other angle, which is of A. That is something that will always be true. And notice that this matches option number 1. That's the relationship that we have in here. Let's take a look at the following question. In question number 5, let's consider a triangle ABC. And within this triangle, we have some information. AE bisects angle BAC. So when we look at this angle BAC, which we have here in red, this section of AE, which is this line that we have in here, it's going to cut that angle into 2 sections. Not just any sections, but equal sections. In other words, the angle that we have here on the left-hand side, it is going to be equal to the angle right here that we have on the right-hand side. And in addition, we are also being given that there's an altitude line called BD. So that's the line that we have in here. And we're going to say that that's the altitude. Then the intersection is going to be 90 degrees. Now let's put down the information that we know. The whole angle C, which we have it here, that is 50 degrees. And the whole angle ABC, which we have it right here, that is equivalent to 60 degrees. What we are interested in is, what is the measurement of angle FEB, which we have it here. Let's start by considering the outer triangle, the whole triangle ABC. And let's put down the information that we know. Angle B is 60 degrees, angle C is 50 degrees, but we can find out what angle A is. The summation of the interior angles is 180 degrees. So therefore, angle of A, it will be 180 minus 60 minus 50, which is equal to 70 degrees. So let's put that down in here. But when we place 70 degrees in angle of A, don't forget that we did mention that AE bisects those angles. So therefore, this little angle that we have in purple, it will be half of 70 degrees. And the same goes with this angle that we do have on the right-hand side. And half of 70 is 35 degrees. So this angle right here, it's 35. And this angle right here is 35 as well. So now, how about if we consider this triangle on the right-hand side only? And I want to consider this triangle because in here, that's where we have the angle of interest, FEB. Now let's put down all the information that we know. Angle B is 60 degrees. But we already found out that this little section that we have here, which is this angle that we have on our figure, it is equivalent to 35 degrees. So now we have all the information that is needed for us to find angle FEB. Angle FEB is going to be equivalent to 180 minus 35 minus 60, which is equivalent to 85 degrees. And now that matches option number 4. Let's look at the next question. In question number 6, we have that a jewelry company makes copper hearts pendant, and each heart uses 0.75 inches cube of copper. So let's write that down. So each pendant, it uses 0.75 inches cube of copper. And then in addition, there's about 0.323 pounds of copper per cubic inch. So this is all we know about the pendant. But we have some extra information that the cost of the copper, it is approximately 3.68 per pound. And what we are interested on is what is the cost if we build 24 copper hearts. So how about if we find the cost of one of those copper's hearts and then we multiply it times 24 and we're going to get our answer. So now let's figure out how we can find the cost of one of those pendants. We know that our pendant, it has a volume of 0.75 inches to the cube. Well, let's find the weight of that. And if we want to find the weight, let's take the volume that each copper heart and then let's multiply by the pound of copper per cubic inch. And that's going to give us approximately 24.225 pounds. And if we want to figure out now the cost of this heart, well, we have that information. It's about 3.68 per pound. But we already know that there's about 0.24225 pounds in this copper heart. So let's multiply those two. 0.24225 times the price, 3.68. And when we do that, we're going to get that each copper heart, it costs approximately 89 cents. So this is the cost of just one heart. The question calls for 24 of them. So let's get this cost and just multiply it times 24. And if we put this down in our graphing calculator, this is going to be approximately 21.40, which is option number 2. Let's take a look at the next question. In question 7, we have a right triangle, LMN, and we have some information about this triangle. Angle M is 90 degrees, so let's place that in there. MN is 12, which is already in there, and LM is equivalent to 16, which we already have that in there. What we would like to know is, what is the ratio of the cosine of n? Well, that's a trigonometric function. So how about we start by labeling our triangle? The angle of interest, it is angle of n. Let me place that in there. Let me label our triangle from the perspective of angle n. What we have right opposite, well, that's the opposite side. What we have in front of 90 degrees, that's our hypotenuse. And what is left is the adjacent. Now that we have labeled our triangle, let's remember our trigonometric functions. There's a small acronym. So, ca, so on. And every 3 letters, it is going to tell us the definition for each of those functions. Well, we're interested on the function of cosine, so let's use the acronym for this second section, which is C for cosine. This is going to help you remember that the cosine of any angle, it is A over H. You know the words? Adjacent over hypotenuse. Well, let's see if we have that information. When it comes to the adjacent, we have that is of a length of 12. But notice that we do not know the length of the hypotenuse. So let's find that. Well, the good thing is that we're working with the right triangle. So we can use the Pythagorean theorem to find the hypotenuse. We're going to get 12 squared plus 16 squared. That is going to be equal to the hypotenuse. Let me call that NL. And 12 squared is 144. And 16 squared is 256. And that is equals to NL squared. When we combine the values on the left-hand side, that is 400. And now to find the hypotenuse, let's take the square root of that. And the square root of 400, it is just 20. So let me put that information in here. The hypotenuse has a length of 20. So now let's plug all the information that we know. The cosine of the angle of interest, which in this case is n, that is equal to the adjacent, which we found it to be 12, over the hypotenuse, which we found it to be 20. And notice that that is option number 1. Let's take a look at the next question. In question number 8, we have a triangle ABC, but we also have this extra line called DE, and we know that it intersects the points at D and E. And now we're given an extra condition about this line. DE, it is parallel to BC. And now what we would like to do is, which of the following proportions are true? Well, let's see what kind of information we can draw knowing that these two lines are parallel to each other. In most of the questions in geometry, when we have parallel lines, we want to see, do I have any congruent angles? And in this case, we do. This, let me call this angle D. It is congruent to angle B. They are corresponding angles. Well, how about if I consider this triangle that we have in the top and the whole triangle that we have on the outside? Let me draw them separately. And now let me put the information that we know. We have said that angle D is congruent to angle B, but notice that angle A is present on both of those triangles. Well, it's fair to say that this angle of A is the same angle that we do have in here. And at this point, we can make a conclusion. This upper triangle that we have in here, it is similar to the overall triangle. We can use angle-angle similarity theorem. And knowing that we have similar triangles, now we can use proportions of similar triangles. So let's say that I get the section on the left-hand side in the small triangle, and I divide it by the section on the bottom of the small triangle. Well, that is proportional to the left-hand side of the big triangle divided by the bottom of the big triangle. And now notice that we match option number 2. That's the ratio that we can obtain. Let's take a look at the following question. Now, what we would like to know is which polygon does not always have congruent diagonals. Well, let's look at each scenario at a time. So let's start with the square. Well, the square, all sides are congruent. And then in addition, all interior angles are congruent. But when I consider one diagonal, notice that I'm creating two triangles, the one on the top and the one on the bottom. Well, those triangles are congruent to each other by side angle side. And when I consider this other triangle, notice that I'm creating the same triangles as before. They are still congruent by side angle side. So we can claim that the diagonals are congruent. But notice that we're looking for the not. So square doesn't work out. How about a rectangle? Well, within a rectangle, we know that opposites are congruent to each other and interior angles are 90 degrees. Well, when we introduce one diagonal, it is the same conclusion as before. The triangle that we have on the the right, it is equal or congruent to the triangle that we do have on the bottom left by side angle side. And when we consider the other diagonal, then the other triangles that we consider, the triangle on the left and the triangle on the right, they're also congruent to each other, and they are the same as the other triangles that we have previously. So we can claim that the diagonals are congruent in this case. But now let's consider a rhombus. Well, within a rhombus, all we know is that all sides are congruent to each other. But when we introduce a diagonal, we do not know if it's going to be congruent to the second diagonal. We know that the intersection, it's 90 degrees, but that's as far as we can go. We cannot make any claims that diagonals were congruent, just like we did with squares and rectangle, because we were able to create congruent triangles. But now we can say that option number 3 is the one that does not always guarantee for diagonals to be congruent to each other. A rhombus maybe could, but not always. Let's take a look at the next question. In question 10, we have that the circumference of a standard across ball. Let's draw our ball. So let me just draw some kind of a circle. And we know that the circumference, it's about 19.9. And now the question is, what is the volume of this ball? Well, when it comes to volume, we can think about it as if it was a sphere. And the formula for the volume of a sphere, it is 4/3 pi r to the third. So if we wish to find the volume of the sphere, we need to know what is the radius of this sphere, which is the same as the radius of this ball. Well, knowing that the circumference is 19.9, we know that the circumference, it is equal to 2 pi r. It is here where we're going to find the radius that is needed. Because for the circumference, we know that it's 19.9. And now, if we divide 2 pi on the left and the right, now we're going to obtain that the radius is 19.9 divided by 2 pi. So now let's get this expression for the radius and just plug it into our formula for the volume, and we should be done. Then the volume is going to be 4/3 pi times 19.9 over 2 pi, all raised to the third. And if we place this down in our graphing calculator, that is approximately 133, which matches option number 2. In question number 11, it says, which polygon always has a minimum rotation of 180 degrees that will carry the figure into itself? Well, let's take a look at each case at a time. Well, let's start with a rectangle. Well, the only way for us to make this figure land into itself is if we rotate 180 degrees. Because when we rotate 180 degrees, this section on the top is going to land exactly at the section at the bottom. But because it's a rectangle, we know that they're congruent to each other. This section on the left is going to land exactly in the section on the right. And we know that they're congruent because we're talking about a rectangle. And the same goes with the figure at the bottom. The section at the bottom is going to land on the top, and so forward. And at this point, we have found our answer, because the lowest degree that we can consider, it's 180 degrees, and that will only be true for a rectangle. So at least in terms of the answer is option 1. But now, let's just take a look at the square. If we rotate 180 degrees, we will be overlapping this square, because this section is going to land at the section at the bottom, the left is going to land on the section on the left, and so forward. But because all sides are congruent to each other, also, if we rotate 90 degrees, we will get the same result. The one at the top is going to land on the left to the bottom to the right to the top. We'll still be getting an overlapping figure, but the question calls for the minimum. For a square, 90 degrees is minimum. Even though 180, it's still carrying the figure into itself. The minimum, it is 90 degrees. Rectangle is the only one that will make that happen. For an isosceles, we cannot do anything about it. And for a regular pentagon, the minimum is not 180 degrees. So now let's look at question 12. Here we have a circle at point O. But we're given the secant line of BCD. And then in addition, we're also given a tangent line. And we know that that is equivalent to 24 degrees. And before we move any further, we have to recognize the situation that we have. Anytime that we're working with a circle, and there is a tangent line intersecting at some point with the secant line, let me use the same expressions that we have here, AD, C, and B, we're always going to end up with the following proportion. If we consider the whole length of the secant line, and we multiply it by the outer section of the secant line, that is always going to be equal to the tangent square. So let's keep that in mind. And when we take a look at the extra description, we're also being given some ratio among the secant line. The ratio of DC and CB is 4:5. So we can express the line segment, which has a ratio of 4, as 4 of x, and that expression of CB, we can express it as 5 of x. And now let's take a look at all this information, and let's make it fit into our conclusion. BD is the addition of these two sections, which is equivalent to 9x. If we multiply that by CD, which is just 4x, that is going to be equivalent to AD squared, but AD is 24. So 4x times 9x, that's 36x squared. And 24 squared, that's 576. Now let's solve for x. Let's start by dividing by 36 on both sides. So we have that x squared is equivalent to 16. And now to solve for x, we can take the square root. So now we know that the value of x, it is equals to 4. But 4 is not what we're looking for. We are looking for the length of CB. Well, CB had the expression of 5x. So let's get that expression and substitute x being equivalent to 4. So option 2 is the correct option. In question 13, we have that the equation of a line 3x minus 5y, it is equivalent to a, and we want to know all lines perpendicular to the line must have which of the following slopes. But let's recall something. When we are dealing with perpendicular lines, when it comes to slopes, they will always have negative reciprocal slopes. So the strategy is, let's find the slope of this equation and let's find the negative reciprocal of that. Let's start by solving for y. So let's start by taking away 3x on both sides. And then let's divide by 5, negative. So now we got 3 over 5, positive. Negative divided by negative, it's positive, minus 8 over 5. And now let's stop here. Because whatever expression we have in front of x, this is the slope of our line. Well, for the negative reciprocal, let's do two things. Let's switch the order of the division. So instead of having 3 over 5, we're going to get 5 over 3. And let's switch the sign. The slope was positive, so the negative reciprocal, it's negative. And notice that that matches with option number 4. For question 14, we want to know what are the coordinates of the center and the length of the radius of some circle which is given to us with the following equation. The only way that we can get this information is if we have the equation in standard form. So when it comes to the standard form of a circle, it is equivalent to x minus h squared plus y minus k squared equals r squared. So the objective of this question is, let's look at this equation that we are given. Let's manipulate it to make it look like the equation of the line, and in that way, we can identify the center at the location of h, comma, k, and the radius at the value of r. So let's do that. So I'm going to start by organizing my equation. Those variables that have an x on them, let me write them first. And then those which have a y on them. And this value of 49 that doesn't have neither an x or y, let me move it to the other side. And I notice that all the x's are together and all the y's are together. What we will do, we're going to complete the square. Let's complete the square with the variable of x first. To complete the square, I am going to get the value that is in front of x, which is 2. And I'm always going to do two things to it. I'm going to divide it by 2. The result is 1. And then I'm always going to raise it to the second. And now let's do the same for the variable of y, which we have it in here. I'm going to do the same. I'm going to take a look at the value that is in front of y, which is negative 16. And I'm going to do two things to it. Always divide by 2. The result is negative 8. And always square it, which right now it is equal to 64. We will use these values to complete the square. So when it comes to the variables of x's, let me add this number that we obtained. And when it comes to the variables of y's, let me add this number that we obtained. But you always want to balance out the equation. Whatever we do on the left, we should also do it on the right. So let me add 1 on the right and also 64 on the right. And notice what happens. If I just concentrate on the values of x's, I can factor this out. This is going to be equivalent to x plus 1 times x plus 1, which is just x plus 1 squared. And when it comes to the variable of y's, I can factor that out. Two numbers that if you multiply gives you 64, and if you add them up gives you negative 16. Well, that is negative 8 and negative 8. So I can express that as x minus 8 to the second. And when I combine the values on the right-hand side, that is equal to 16. Now, if you have difficulty factoring out, here's a trick. The value that we will obtain inside the parentheses, it will always be the value that we're squaring. The same goes with y. It was negative 8, and that was the value that we square in our calculation. And now we can go one step further. Instead of calling it 16, let me call that 4 to the second. And we should be done now, because now the center, it is equivalent to negative 1 and positive 8. We always switch the sign. And the radius, it is equal to 4, the value that we square. And that is going to leave us with option number 2. In question 15, we're given a right triangle, MDL, and we're also given that DG is an altitude, so that means that it's 90 degrees at the intersection, and the hypotenuse is ML. So if ML is the hypotenuse, then the angle opposite of this is 90 degrees. So that's this whole angle that we have in here. Let's place down the extra information that we have in this triangle. MG, it is equal to 3. So let me place it there. And GL is 24, which we have it in there. And now the question is, what is the length of DG, which we have it here? Here we have to recognize the scenario that we have. Anytime that we have a right triangle and we introduce an altitude to it, we're always going to obtain geometric mean. So let me write down the 3 geometric means that we can obtain. So geometric means are always a fraction equals to another fraction. When we consider the altitude dg, we'll always place it at the bottom left and upper right. That is going to have a geometric mean among the two sections of the hypotenuse, mg and gl. And then in addition, another possible geometric mean that we could obtain, it is in terms of the side of the triangle, MD. And it will always be geometric to the whole hypotenuse of the triangle and the section of the hypotenuse which we have in the left triangle, MG and ML. And the third geometric mean, it's in terms of the other side of a right triangle. And that has a geometric mean with the whole hypotenuse and this section on the right-hand side, because we're looking at the right triangle. But notice that we're looking for DG. And when it comes to DG, we have a geometric mean about that. MG is going to go on the top, which we have that length for that. It is 3. And GL is going to be on the bottom left-hand side, which is 24. So out of the 3 geometric means that we have in here, let's just use the first one. Let's plug our information. MG is 3. DG is what we're looking for. Let me actually just call that X. DG is X. And GL is 24. And now we can cross multiply to find the value of X. 3 and 24, that is 72. And X times X, that is X squared. So to solve for X, let's take the square root. So we can say that X is equal to the square root of 72, which matches up with option number 4. If you need a refresher about the geometric means that I wrote previously, I'm going to leave a link on the description with the lesson that will teach you about those geometric means. In question 16, we have that a segment AB is the perpendicular bisector of CD at point M. Let's visualize that. We have a line segment, let's call it CD. And CD, it's getting bisected perpendicularly by some other line called AB. So if it's a perpendicular bisector, there are two things going on. Their intersection, it's 90 degrees. And notice that here it says of CD. So CD is the one that is getting bisected in half. In other words, we got two congruent sections. And their intersection, it's a point M. So now we want to know which of the following statements are true. So let's go one scenario at a time. Let's consider scenario 1. CB is congruent to DB. Well, let's draw that. CB, it will be this section that we have in here. And DB will be this section that we have in here. Well, when we consider those two sections, notice that we can also consider two triangles, the one on the left and the one on the right. Let me draw them individually. And now let's put the information that we know. Well, here we have 90 degrees. Well, the one that is opposite is also 90 degrees. Therefore, this angle should also be 90 degrees. CM is congruent to MD. That is what we got from perpendicular bisector. But here, the section of MB, it's present on both triangles, so it must be congruent to each other. And when we have this scenario, we can claim that these two triangles are congruent to each other. We have side, angle, side on the left and side, angle, side on the right. So here we have two congruent triangles. Then by CPCTC, corresponding parts are congruent. Well, the section of CB corresponds to the section of BD. They are in front of the angle of 90 degrees. So we are done. Option 1 is the correct option. CB is congruent to DB, and the reason behind it, because corresponding parts of congruent triangles are congruent. On question 17, we're given a circle, and then in addition, we'll also be given that AC and BC are chords. So this line segment of AC starts at the circumference and ends on the circumference, and the same goes with CB. And then in addition, angle ACB, which we have it here, it is of 70 degrees. Now let's put down some information that we were given. OA, it is equivalent to 9. But I want for you to see that OA can also be seen as the radius of the circle. The radius is equivalent to 9. So now we want to know is, what is the area of the shaded region OAB? So we want to know what will be the area of this section. Well, when it comes to strategy, if we want to know the area of that section, we need to know the angle that creates that section. So now let's think about how we can get that angle. So how about we consider the angle of 70 degrees? Notice that this angle is an inscribed angle. And by relationship, the arc that is opposite to it, it is double the measurement. So therefore, the arc of A to B, it will be 2 times 70, which is 140 degrees. And now we have all the information that is needed to find the angle that we were looking for. Because notice that the angle that we are looking for, it is a central angle. And central angle will always be equal to the opposite arc, where the opposite arc is what we found as 140. And now we have all the information that is needed to find the shaded region. The shaded region, it will always be equal to the central angle divided by 360 times the area of the circle. Let's place down that information. Our central angle, it's 140 degrees. Let's divide that by 360, and to find the area of the circle, that's pi r squared. But we do know what's the radius of the circle. We found out to be 4. So we'll have 4 squared. And if we put all this in our graphing calculator, we're going to end up with 31.5 pi, which is option number 4. In question 18, we're given that there is a quadrilateral called BEST, best. So let's start by drawing that. And the diagonals, they intersect at some point. Let's call it D. Now we would like to know is which statement will not be sufficient to prove that the quadrilateral best, it's a parallelogram. Well, let's remind ourselves, what do we need to show to conclude that we have a parallelogram? Well, if the diagonals bisect each other, then we can claim that we have a parallelogram. And also, if opposite sides are congruent, we can also conclude that we have a parallelogram. And also, if opposite sides are parallel, then we can conclude that we also have a parallelogram. So these are the 3 different conditions that will guarantee for us to have a parallelogram. Now let's go down the list and see which one does not have this condition. In option 1, BD is congruent to SD. And also, ED is congruent to TD. Well, that is condition 1. Diagonals bisect each other. So we know that this will guarantee for us to have a parallelogram. So this is not the correct option. Let's go to the next one. BE is congruent to ST. And ES is congruent to TB. Well, that's the same as saying that opposites are congruent. That's another condition that will guarantee for us to have a parallelogram. So this is not the correct option. In our third option, we're saying that ES is congruent to TB, and BE is parallel to TS. So here we're saying that one pair of opposite sides are congruent, and the second pair is parallel to each other. That does not mean neither condition 1, 2, or 3. So we know that this condition will not be sufficient to show that we have a parallelogram. In question 19, we are being given the equation of a line 3x minus y equals 2, 6. And this line is the image of some other line after a dilation with a scale factor of 1/2. So let me call this k equals 1/2. But what's important to know is that this dilation was centered around the origin 0, 0. So now we want to know what is the equation of line M. Let's come up with some strategies. Anytime that we have a dilation, when it comes to lines, the image and the pre-image will be parallel to each other. Well, to show that two lines are parallel to each other, they must share the same slope. So let's start with that. Let's take a look at the equation that we are given, and let's find the slope of that. So let's take away 3x on both sides. And let's divide -1 on all sides. So we'll get 3x minus 6. The slope of the line that we are given, it's positive 3. And notice that within option 3 and option 4, they both use the slope of 3. In option 1 and 2, we have a slope of 3 over 2. So we know that 1 or 2 is not the correct one. Now it's down to option 3 and option 4. Well, because the dilation was centered at the origin, then the location of the y-intercept will get affected by the scale factor. Well, the y-intercept in our equation was of a value of 6. The scale factor was 1/2. When we multiply those two, we will get the y-intercept of the new line, which in this case, it's -3. And that matches option number 4. In question 20, we have a cylindrical pool which has a diameter of 16 feet. So let's start by drawing this pool. And now we know that the diameter, it's 16 feet. And then in addition, the height, it's 4 feet. And now we're given this information that the pool was filled 1/2 foot below the top. If we subtract 1/2 of feet from the top, and knowing that the whole height was 4, then it's fair to say that the height that we will fill the pool is going to be of 3.5. So at 3.5, this is where we're going to find the water within this pool. And now the question asks, how much water does the pool contain to the nearest gallon? Well, notice that we are given a conversion. Every time we have 1 feet cubed, we're going to have 7.48 gallons. So the strategy here, let's find the volume that the water uses in this pool, and then let's multiply times 7.48. So let's do that. The volume, well, it is a cylinder, and the volume of a cylinder, it's pi r squared times the height. So let's find out what that is. So we're going to get pi. The radius, it is just going to be half of the diameter, which is going to be 8. And for the height, well, that is the height that the water will be using, which is 3.5. So after putting this in our calculator, then we can say that the volume is 703.71 feet cubed. So now let's use this volume that we obtain in here, and let's multiply times 7.48, because we know that anytime we have 1 feet cubed, we're going to obtain 7.48 gallons. And when we place this in our graphing calculator, it will give us approximately 5264, which matches option number 3. In question 21, we have that the area of a triangle TAP is 36 centimeters square. So let's start by drawing that triangle. And now we have a second triangle. Let's call it Joe. And it is formed by connecting the midpoints of the outer triangle TAP. So here's a midpoint, here's a midpoint, here's a midpoint. So let's call this GOE, G-O-E. And now let's create a triangle. Well, because we are connecting the midpoints, then it's fair to say that TO is congruent to OP, EP is congruent to AE, and AJ is congruent to JT. And now notice that we have 4 different triangles. Triangle 1, triangle 2, 3, and 4. Well, because we're connecting midpoints, then we can use the midpoint triangle theorem, where the midpoint will be half of the opposite side. In other words, JO will be half of AP. So we can use the double notation in there. And we can go around this triangle. OE, it is half to TA. So it is equal to just one of those notations. So let's do 3 lines. And the same can be said about JE and TP. And now notice that we have 4 congruent triangles. Well, the area that we're looking for in here of triangle GOE, if these 4 triangles are congruent to each other, then it's fair to say that this green area, it is 1/4 of the whole triangle. Which is equal to 9. And that matches option number 1. In question 22, we are being given a line segment, AB, where the endpoints are located at point A at -3, 4, which we have it here on the left, and B at 5, 2, which we have it here on the right. Now, what we would like to know is what would happen to this line segment if it gets dilated by a factor of 2 at a coordinate point of 3, 5. So let's place that in our picture. So now let's think about how we're going to identify the image of this dilation. So let's start by identifying the center of dilation, which is at 3, 5. And now let's just choose one point. So I'm going to concentrate on point A. I'm going to see what vertical and horizontal movement I need to do to go from the center of dilation and reach point A. And in this case, notice that I'm moving 6 units to the left and also 1 unit down. Well, because we have a scale factor of a value of 2, we need to perform this movement 2 times. So we already did it once, from the center of dilation to point A. Well, let's do that same movement one more time. So from A, let's move 6 to the left, and let's move 1 down. And it is here where we're going to find the location of A prime, at the location of -9, 3. With just by knowing this point of A, we can start eliminating some of the options. Here A, we're claiming to be -7, 5, that's not what we got. A prime, -1, 6, that's not what we got. A prime, -6, 8, that's not what we got. But notice that in option number 4, A prime is -9, 3, which is exactly what we got. So we can claim the correct option, it is 4. Now let's just double check that we also got 7, -1 for B prime. So we're going to do the same analysis. Let's going to see what movement do we need to do from the center of dilation to point B. Well, that movement is 2 units to the right and 3 units down. Well, this is just one movement. Because we have a scale factor of 2, we need to repeat this movement one more time. So now from B, let's move 2 units to the right and 3 down. And it is here where we're going to find the location of B prime, which notice, that is the location at 7, -1. So we have just confirmed that it was option number 4. In question 23, we are being given 4 different chords, AD, AC, BC, and DC. And then in addition, we are also being given a tangent line at EF. But what's important about that description is that we have two parallel lines, AD and BC. And what we would like to know is which of the following statements are true. Well, let's start with parallel lines. If we have two parallel lines, then there must be congruent angles. And in this case, I am going to be consider angle DAC and angle BCA. They are alternate interior angles. Now, because of the chords that we are given, I can identify that the angle DAC, it is an inscribed angle. But also notice that angle BCA, it's another inscribed angle. But notice that these two angles that we have just defined here are congruent, because we said they were alternate interior angles, so therefore their opposite arcs are also congruent. The arc of AB is congruent to the arc of DC. But also notice that the intersection of this arc of DC, it's also created by the intersection between the tangent of DF and the chord of DC. Then we can say that that angle is also congruent to angle A and angle C. So here we have a transitive property. Our first angle, ACB, is congruent to our second angle, angle DAC. And we have just shown that that's also congruent to our third angle, CDF. But by transitive property, then we can just say that angle CDF is congruent to angle ACB, which matches option number 2. In question 24, we are being given a triangle ABC, but notice that we are given information that point D and point E are midpoints of AB and AC. So if these 2 points, D and E, are said to be midpoints, then they cut its individual line segment in half. So if AB gets cut in half, then the section of AD is congruent to DB. And if E cuts the line segment of AC in half, then AE is congruent to EC. And now what we want to know is which of the following similarity statements are true. Well, because we want to know about similarity statements, let's try to identify 2 similar triangles. And there are 2 triangles that I can identify here. Triangle ADE, let's draw it here on the side. And triangle ABC, let's draw that on the side. Now let's see how many congruent angles and congruent sides we can identify between these 2 triangles. Well, the first thing to notice is that angle of A, it is present on both of those triangles. So we can claim that it's congruent in both of those triangles. So angle A, it is congruent to angle A. Now remembering that D and E are the midpoints of those 2 individual line segments, when we connect those 2 points, we are creating the median of a triangle. And the median of the triangle will always be parallel to the base of our triangle. And now that I have 2 parallel lines, then maybe I can start identifying congruent angles. Well, here we have 2 congruent angles, angle D and angle B. They are both corresponding angles. So let's place that in our diagram. Angle D, it is congruent to angle B. And then in addition, angle E, it is congruent to angle C. Let's place that in our diagram. And just by looking at our triangles, we can already see that the AA similarity statement, it is going to be true. There's at least 2 congruent angles in each triangle. So now let's just concentrate on the sides of these triangles. In the big triangle, let me identify point D, so let's say it's about here, and point E, which is about here. Within the statement that we were given, we were able to conclude that the line segment of AD, it is congruent to the line segment of BD. So it's fair to say that this left-hand side of the small triangle, it is half than the left-hand side of the big triangle. And the same can be said about the right-hand side of our triangle. Because E was the midpoint, then we can say that AE, it is half of the line segment of AC. So notice that when it comes to the sides of those triangles, there is a scale factor. If we go from the small triangle to the big triangle, then we can say there's a scale factor of 2 when it comes to the side. So now we have met the criteria for side angle side. Notice that we have two sides that have a same scale factor and the angle between them, which in this case, its angle of A, is congruent to each other. So now, how about the bottom of those triangles? Well, recall that DE is the median of the triangle. It is true that those lines are parallel to each other, but then in addition, it is true that the median, it's always half than the length of the base. So we have the same scale factor. If we take a look at DE, it is going to be half of BC. So now we have also met the criteria for side, side, side. And when we put all this together, then we can see that option number 4 is the correct option. Hello. If you would like to continue learning about mathematics, you can check out the videos on the left.